For this. Cool. So group one, observations.
We found, oh, sorry, go ahead, Noah.
Oh, no, you go ahead.
Okay, we found that the more bulbs, the less deflection.
Cool. Two.
You saw the same thing.
Yeah. Anything you want to add then? Three, four. Anybody wants to add anything to the observation?
Yeah, we just noticed that the bulbs got dimmer the more there were.
Okay. So what does it mean? First of all, what did you notice about the deflections in the different wires? Leila.
The deflections also got smaller the more bulbs there were.
So more bulbs, less bright, more bulbs, less deflection, right? How do we explain that? Jordan, what do you think? Why do you think that is? That more bulbs dimmer and more bulbs less deflection? First of all, do the two observations make sense with one another? That if they're dimmer, then you have less deflection?
Yes,
Why?
I think it does make sense. I'm not completely sure on how to explain it, but they make sense together, but I don't know how to explain it completely.
Okay. Somebody help her? Yeah, Gio? And then Ian after that, and then Ollie?
I think it has to do with how the lights are kind of using up the energy from the battery as it flows through the wires.
Okay. Ian?
Kind of like what Gio said, it's like when there's one, there's like enough electricity to go around and to like change other things. But when there's three light bulbs or two light bulbs, they're like the two light bulbs are sharing this electricity, so then it's leaving not as much electrical current to go and change the direction of the compass. It's like it's weaker in a way. It's using.
Ollie, do you want to add anything?
I mean, just kind of what Ian and Gio said. The light bulbs are kind of acting like a sponge would in a river or something like that. Just soaking up a little bit before the current goes to the next bulb.
Okay, I want to talk a little bit about the whole concept of soaking. What do you guys mean by, because that's a little bit of a misconception. What do you guys mean by soaking?
Kind of just like taking up a little bit of the current.
So the question I want to ask is, when you go from 1 to 2 to 3 light bulbs, is that because you are taking charges away from the circuit? That would be one, right? I think that's what you guys mean by soaking, right? You're like taking, like each light bulb takes charges away. Is that what you mean, Ollie? Or is there another interpretation that we can have about why there's less current? Yeah, Zach.
Well, I think it kind of makes sense of why there's less current, because how it works is if you have the same amount of power and electrical flow coming out of the battery, then when it goes through a light bulb, it doesn't just pass through the light bulb, because the light's turning on and creating heat and light. That's giving off energy. So some of the electrical energy has to be rerouted and is basically being dispersed out of the circuit in the form of heat and light from the light bulb, kind of.
So there's definitely energy being thrown out of the circuit in a form of light and heat, for sure. Right? Yeah. Think of the adding a resistance as think of a resistance as a small door. So you guys haven't been in a building yet, but you will soon get in a building, and you'll see that. Imagine like you're in room 300. So our class will be in room 300, which is a big lab, right? And there's going to be, there's going to be 15 of us, 16 of us in that room. Let's say there's a fire emergency. So we have to get out of the door, right? And the question is it, so imagine like a small door, right? So it's hard to get through one small door. What if you had two small doors in a row? Would that make life easier or harder to get out of the room? Ian,
It could make it easier, but like if everyone tries to get out at the same time, there's gonna be more people trying to get through a bigger space, which could seem like a better idea, but then more people will try to go into that space instead of like having more of like a confined thing where like one person can go out at a time, that's it. But if there's two, if there's more than three people are gonna try to go in, and then that's gonna block it off, which creates like a slower reaction, which like in this case could be like the degrees that it moves, the compass is how efficiently people get out of the door. And so when there's three people trying to get through two doors, that should only be like two people getting through that, just but like our minds are probably like, oh, it's a bigger door, then it's showing that like it's going to move less degrees.
exactly. I actually really like the analogy, like the idea of the deflection of the compass is measuring how many people go through the door at any given time, right? Um,
Like with ease too, like if it's easier.
right. And
I
so
guess.
with ease, right? So the idea is that the more stuff you put in the way to prevent the current from going through, i.e., the more resistance you put in, the less current you're going to get, right? And if you have one light bulb, so either you do your experiments with the round bulbs or with the long bulbs, if you just keep one type of light bulb, it sounds like less current, less deflection, less deflection, less brightness. That sounds right? Okay, so let's look at the series versus parallel. Group 4, what did you guys see? Series versus parallel. Group 4, that would be group 4. That would be Ian, Jordan, Marlo, and Zach.
For the first one, I saw that there was like no deflection at all. Wasn't exactly sure why. It kind of confused me a little bit. I mean, my one thing was like the to light up the longer bulbs, it takes like a little bit more electrical current
Okay.
than I noticed that they're a lot harder to light up. So that was really my only like opinion on it, or it just what I noticed is that it didn't really move, and I was just kind of confused why not.
And what about the comparison of series versus parallel? What did you guys see in parallel that you did not see in series?
That it lit up a lot more, which also kind of confused me because I was like, well, like what is making this light up more? Maybe there's like more interactions going on, but I don't know. It was kind of cool. It was like the one in the back wasn't hooked up really to the battery. It was hooked up to the current coming from the battery through the other light bulb. So I was like, how is that creating more energy than like the one that is just straight to the battery? So that was confusing, but also cool.
Group 3, anything you want to add?
Yeah, I also noticed that the deflection was larger for the parallel one.
Mhm.
And I think this is because, like Ian kind of mentioned this a little bit, but the electrical current, like for the second bulb, well, it doesn't look like it's attached to the battery. It's like I think that the current is going through that wire and not passing through the light bulb, just going directly to the wire that's like right next to it. So that takes away part of the resistance to get to the other bulb.
Interesting. Group 1 and 2, anything you want to add to that, to those observations?
Mostly just that I noticed the same thing. Like, there, I didn't see much deflection in either one, but there's more in the second one. That's probably because it doesn't have to pass through the light bulb.
Okay. So yeah, right. So first of all, you all reported that it looks like it was harder to see a deflection through the bulbs in series when you used the long bulbs, right? As opposed to the round bulbs. So that was one thing. What does it mean that it's harder to see a deflection?
It means that the long bulbs are absorbing more of the current, and or rather acting as a stronger resistor, that sort of thing.
Yeah, so I like the acting as a stronger resistor better, right, Mark, than
Mm-hmm.
absorbing, because absorbing again goes to that idea of like you're taking away or you're storing to the side.
I see.
Nobody's storing anything. The only thing that's storing anything is the battery, right?
Yeah.
But the resistance is preventing the current from going through. So if you see less deflection, that means there's less current, right? Less deflection, less current with a long bulb, which is interesting. Right?
Okay.
Okay. And then there's why do you see more electricity? Why do you see more activity in the parallel circuit? Right. So I want to share. Let's see. I'm going to stop recording because I tried that with my other class and that did not work. So I'm going to stop recording.